This gigantic diaphanous mass occupies a space that is 1,000 times greater than the solar system. It is one of the many interstellar clouds that the universe contains. Hundreds of organic molecules accumulate in its interior. Many of them are identical or similar to those that make up the living beings on Earth. As knowledge of the universe advances, it is confirmed that the ingredients of life do not exist only on Earth. To the contrary, as living beings, we are made from a raw material that is abundant in the universe.
We can think of the origin of life as perhaps in three different ways. In one extreme, life is a miracle. Life comes from God, a unique event. If so, science can't address the question because science can't address miracles. Miracles, by definition, defy natural law. But life may have been consistent with physics and chemistry, and yet a very rare, perhaps a unique event. Very improbable because of chance. And if so, again, science has trouble addressing the question because how can one go to a laboratory and study an improbable event? So only in the third case, if life is an inevitable consequence of chemistry and physics, if anywhere there's water and rock and air, life arises, then science can hope to answer the question.
When we ask ourselves about the mystery of life, we almost always look at the Earth for the answer. We have no other reference, although the Earth, with its inexhaustible variety of forms, plants and animals, is like a box of surprises and new questions, more than a direct answer. No one is sure where life begins and ends on Earth. Is it possible that something exists that is not just a copy, more or less advanced, than what we have on Earth? We already know, with much precision, what caused life to develop on our planet. Everything began with water, and with the release of certain chemical elements, like carbon and oxygen, which combined to form organic molecules. These molecules, thanks to the light of the sun, electric discharges from the atmosphere, and the energy from the interior of the Earth, became incipient living beings. Thus, starting with water, chemical elements, and a source of energy, the most elemental living organism known today appeared: bacteria. In 1953, the American chemists Stanley Miller and Harold Urey tried to reproduce the origin of life in a laboratory. They placed water vapor, methane, and ammonia in a test tube and ran a continuous electric current through it. Almost 1 week later, the water had acquired color and new compounds had appeared, including 2 amino acids, which are the basic building blocks of life. This combination, however, continued to be just as lifeless. Perhaps something similar to this experiment occurred on Earth. But if this is true, it was nothing more than another failed attempt that kept the planet, during its early stages, as a barren, lifeless place. Experiments aimed at reproducing the origin of life have helped science to define, with greater precision, the frontier between living material and lifeless material, between life and non-life.
There are a series of specific characteristics that make a living being different from a non-living being. For example, replication. A living being should replicate, generate progeny. It should produce offspring, whether they are molecular children or cellular children, meaning that replication should not be exact from father to child because we would lack diversity. In replication, there should be a series of mutations that introduce changes between the parental generation and the generation of the descendants. And these changes will make the descendants different from each other. Being different amongst themselves means they will react in different ways to stimuli, to selective pressure, and to environmental changes. Therefore, some will adapt better than others. Living beings, therefore, replicate and evolve, and they have a metabolism. This means that living beings are capable of carrying out a series of processes. Through the consumption of energy, they produce biomolecules. From a disorganized outside world, they produce organized molecules, which they use to grow and for their own metabolism. It's possible that these are the three fundamental characteristics of living beings: replication, mutation, and therefore evolution, and metabolism.
At the limit of these requirements, we find the viruses, which most scientists don't consider living beings. It's true that they reproduce and evolve, that they transform with several mutations, but they only do so when they infect a cell, which they use so that they can reproduce themselves. Thus, viruses only act as living beings when they act as parasites on a cell.
The question of this transition from non-life to life, that's in some sense a philosophical question, and yet many of us who work in the field have our prejudices. And mine is that the transition occurs when competition and natural selection begins. You can imagine inanimate nature, molecules, rocks, water. That's not alive, that doesn't compete. But at some point, a level of organization occurred in molecules, molecular systems that could replicate themselves. And when that happened, and because of the richness of organic molecules available, you had slight differences in these self-replicating molecules.